Hello viewers, welcome back to Coding Search, the next era of learning. Today in this video I am going to explain the overflow and underflow of unsigned int data type. So let me create a new file first. Say overflow demo.c. So friends, before moving ahead, first of all I'm explaining modulo division or the modulus division in computer science. Say 10 modulus 10 percent sign is used for the modulus operator. That so if 10 is modulus divided by 10, the result will be equal to 0, because modulus operator or the modulus division gives a remainder as a result. If I divide 11 modulus division by 10, if 11 is modulus divided by 10, the result will be equal to the 1. Friends, as per the C99 standard, the overflow of unsigned int data type has been well defined, that if the number that cannot be represented in unsigned data type, means if the number is larger than the upper limit of the unsigned data type, then that will be reduced to the modulus of the largest number plus 1. So let me give you an example. So has include studio.h and has include limits.h int main. Here I am going to declare a unsigned int variable. So unsigned int a, and I am assigning the upper limit of the unsigned int data type, that is uint max. Uint max is the upper limit of the unsigned int data type defined in the limits.h header file, and another variable of unsigned int, say b, equals to, I am assigning the lowest or the lower limit of the unsigned int data type, that is 0, and let me print both the value. So printf slash n value of a equals to %u, that is the format specifier for the unsigned data type, and the variable name is a, and let me copy, and the value of b b I have to put the comma before the a and b, and now I'm going to increase the value of a by 1. That will cross the limit of unsigned int data type. Say I'm increasing the value of a by 1, so a equals to a plus 1, and I'm decreasing the value of b by 1, and b equals to b minus 1. Means here when I increase the value of a by 1, this will exceed the upper limit, means there will be overflow, and how the overflow is managed in unsigned int I'll discuss in when the output comes. And here when I decrease the value of b by 1, it will be the case of underflow. So semicolon. Now let me print once again the value of a and b. I am copying this. Printf backslash n value of a after increasing. Let me copy once again value of b after decreasing, and the variable name will be here b, and at last return 0. Return, save it, and open a terminal, gcc, and the file name is overflow demo.c. Enter. It's compiled successfully, and now run the program /a and press enter. Here in the output you can see the upper limit of a, that is 429.496.7295, and the b equals to 0, that is the lower limit of the unsigned int data type. What I have initialized here, a equals to upper limit of unsigned int data type and b equals to 0. This is the lower limit, you can say lower limit of unsigned data type, And when I increase the value of a by 1, the value of a after increasing it becomes 0. And when we decrease the value of b by 1, it becomes the upper limit of the unsigned int data type. You can take an analogy of clockwise. If the hour needle is struck to 12 and if that 12 is modulo divided by 12, the result will be 0. And if the hour needle is struck to 13 say, then 13 will be modulo divided by the upper limit, that is 12, then the result will be 1, because when 13 is modulo divided by 12, the remainder will be 1. Remember that modulo division returns the value remainder. Likewise, the here if the number is not represented in the unsigned variable or the unsigned data type, then that number will be modulo divided by the upper limit plus 1. So I hope you understood this concept. Thank you very much for watching. Have a nice time.